my mother saved from me from when I was a kid. So I was kind of going through and seeing my things from like first grade and second grade and fifth grade and all these papers. And I was kind of thinking about that because I wasn't, nobody thought I was going to be a math, go into math when I was a kid. If you look at the grades that I got, and I shared a couple of these with Aaron, like the math scores were like bad. It's like I got like 50% on some papers and like 80%, but like my spelling was really good. Like I got like 100% of my spelling tests. My history stuff was good, but math wasn't. It was okay, but what I realized today for the first time was that every single thing I have from math from school, from kindergarten all the way through high school, was just list of problems. I don't ever remember doing a single math project. I don't remember doing an application, a report, anything but just a list of problems. There's some story problems in there every once in a while, but I just kind of realized that today. And again, thinking about my own childhood and kind of how I found Montessori and why I really like this work. It's that, math wasn't my thing when I was a kid. I found it kind of, just doing like worksheets and problems. It's like, yeah, I can do that, doing fractions on a page, whatever. It just kind of was something to do, it's what you have to do when you go to school. But I also remember at the same time, like I loved on our public television stations, they had this show called In Search Of with Leonard Nimoy, who played Mr. Spock from Star Trek. I don't know if anybody here remembers seeing that show, but like I loved watching that when they'd have like these mysteries of like the universe and how things happened. And in the early 80s, Carl Sagan came out with his Cosmos series. And I just like loved learning. That's where the first time I heard of Google before. Carl Sagan talked about the story about the kid who came up with the name for Google, which is one with 100 zeros after it. And they would talk about Kepler and the planets and all the platonic solids. And there was just, I loved watching that and I couldn't wait to do more. But yet that's not the same thing we were doing in school. There was this disconnect, right? And even when I was in middle school, speaking of adolescence, I would read, this is the kind of kid I was. I had a magazine called Discover Magazine, and it was basically a science journal, but written, for the layperson. And I remember reading an article in there about pi, which I thought was really cool. And somebody came up with a formula to figure out any digit of pi without actually having to calculate all the digits of pi. So if you want to know like the billionth digit of pi, you could just put a billion into the formula and it instantly calculated the number. And they didn't use base 10 for it. They used base 16 for some reason. And they didn't go into a lot of detail. And I don't even know if today I could understand all the details of it. But I just remember being fascinated by that and wanting to learn more. And finding that math and science as well, because there's a lot of science in there, in the magazines about time travel, right? And like quantum physics and all the stuff like that. And what were we doing in science class? Like doing an experiment with like a brick and you drop it and you record what happens or you weigh something. And I'm like, well, I want to do like real science, but there wasn't that outlet for that kind of stuff. And so, I know that students and children and adolescents, like they're naturally curious about something. Now, everybody's not going to be as jazzed about Carl Sagan and about math as I am, or that many of us are. But if we're introduced to things in the right way, if things have some intriguing value, if it's something where it's just like we want to do it for our lives, that's such a different approach than here's something that you want to do that we're going to do because we kind of have to do it. And math was one of those things where it's like, well, you have to do math so you can get into a middle school. And then you have to do that so you can get into a high school. And you have to do math so you go to college. And it's like, that's the only reason was for math. So you could maybe use it someday at the next level, possibly. But the adults in my life, they didn't use math. They didn't need to know this stuff. So like, it's very contradictory. And so when I became a teacher, one of the things that I wanted to do was to try to give that kind of an attitude of learning just being kind of part of life to my students. Where it's just like, hey, why can't you just, I love the Schoolhouse Rock. I don't know if anybody's familiar with that. The songs with like, they had the math rock, the multiplication songs they had, and the history songs and stuff. It's just like I love sitting on Saturday morning with my cereal in front of my TV in my pajamas and watching Schoolhouse Rock 5 minutes till the hour. And I was learning, but it was done in a way that like made me want to learn. And so why can't school just be like that, where you just come in and there's a bunch of stuff to do. You do a bunch of work, and at the end of the day, you learn something because it was just awesome to do. And that's what I found with Montessori. Montessori has that attitude where it's not the teacher driving the students to do work, but instead it's the teacher preparing an environment, right? Putting offerings in front of students, but then the students drive the work. It's their passion, it's their excitement about what they're doing, that really drives that forward. And I think that's I started off as an elementary teacher in the public schools, not in Montessori, and when I was doing that, I had a little more freedom to do that in a way because I'm the only teacher in the classroom. So if I wanted to make a 3-hour long class or do a project, I could do that. I found that when I moved to the adolescent level, we had separate subject teachers for everything. And it's really, you don't have as much control over the day. You basically have your 45 minutes a day or your hour, and that's really it. So it's hard to do integration with the sciences. It's hard to get out and do major projects and major work. And so when I found Montessori at the adolescent level, where basically you did have more teachers, but they were working as a team. You're working together to have this environment. So it was no longer my math classroom and her science classroom and this history class. It was, we're here in this environment. We each have specialties, but we're here to have the students do their work, and we're going to fit in and plug in what we know to help the students along the way. And I absolutely love that about Montessori. So, with that in mind, we really want to think about what's different about them. What makes Montessori different than other traditional math programs or even non-traditional math programs? What's really special about the Montessori approach? And I think there's several things. There's a lot of small details that are really important, but there's a couple of big ones. And one of them for me is that Montessori overall is about development. And that's the thing I think we always need to keep in mind. That no matter what we do, no matter who we are, as adults working with children and adolescents, our job is to help nature develop. So, pardon me. Sorry. Excuse me, just one moment, please. Okay, sorry about that. So our job is, nature's going to do what it's going to do. And it's going to take children and turn them into adolescents and adolescents into adults. And we have two choices as adults in their lives, is we could either get in the way or we can help what's going to happen naturally. We can't alter what's going to happen. And so if we're talking about mathematics, my main goal is not to teach math. To get the students to learn math skills. My main job is to help them to develop. And we do that, of course, in a lot of different ways, by building relationships with students, by understanding who they are as adolescents. But as a teacher of mathematics, as that is being my specialty, my job is to focus in more on the mathematical mind. Okay, so that's the aspect of development that I am focused in on. So human beings, so what do we mean by the mathematical mind, right? Human beings have the kind of mind, we abstract, okay? And then we apply those abstractions that we've acquired. So what this really means is we can pull the essence out of things. The word abstract literally means to pull from. Ab meaning, to draw from. Ab and stract, to draw from. And the classic example is like a color, like red, okay? So like you can see a red blouse or a red chair or a red leaf. But the idea of redness, like that's something we have to pull from those different objects and say, oh, these all have red in common. And you can't really imagine red without imagining a red object. And Montessori tries to do that in the primary. She has like color tablets, which are just a plain square, just to isolate the idea of the color and to pull that out. And in mathematics, we see this. As human beings, we see circles. We see them in the sun and the moon. We see it in people's eyes. We see it in flowers. We see circles. We see them in nature everywhere. But the idea of a circle is something beyond what we see a circle attached to. And that's the beauty of human beings. We can take the idea of a circle and then apply it to new ideas. Um, so now abstraction themselves don't have to do with the mathematical mind, because human beings abstract everything. We can abstract colors, and that's not really the mathematical mind. But exact abstractions have to do with the mathematical mind. In other words, mathematics takes it a step further and combines abstractions with a reasoning mind. And so that's what mathematics really does. The mathematical mind also works on the concepts of exactness and precision and order. And all human beings possess a mathematical mind. It's just part of who we are as humans. This is something that we do naturally. Now, does everybody express their mathematical mind through mathematics? No. We can express it in different ways, but we all have the mind, this ability to problem solve, to reason, to be exact. And so, if I asked here on the call, who here today or this week or this month, if you're not, except in a math class, who's used the quadratic formula? Who's used any trigonometry this week? It's very unlikely. But if I said to you, who here had to reason something out? Who here had to be precise about something? Who had to take an idea and be able to communicate that clearly? Those are all things that can happen through mathematics, through this idea of how do we develop the part of the brain and the reasoning mind to think in a precise and orderly way. Now, along the way, the skills of mathematics do apply to many things as well. It's not just like, it's just a pure exercise in building the mind. There's so many reasons why mathematics is helpful, especially in our society today. And we want to make sure that our adolescents especially are connecting to this, because especially for younger adolescents, they want to know what's in it for them. Why should I learn this? That's a question that I used to get a lot when I first started teaching math. It's like, well, when am I ever going to use this? Why am I learning this? When do I need to know this? And, as I taught more and more, I kind of realized, well, yeah, that is a good question. Why do you need to know this? Like you're not going to use this. What's the point of what I'm doing? And so instead I said, well, there needs to be a reason why you're learning this, and it needs to be in the now. It can't just be just in case one day you're going to come across this question. And so we try to do as much as possible in the adolescent environment where mathematics comes out of a necessity, whether it's a need in the environment that we have. So for example, as a school community, the first school I worked at, we had a very small plot of land, a little bit of a farm. Students had some animals, had some small crops. By crops, a garden, I should say. And I was in California at the time. And in California, there's a lot of issues around water usage. We were in a drought at the point. Water can be very expensive. We had to be responsible with our water usage. And so we had this problem of like, well, how are we going to get our water for our crops, for our animals? And all of a sudden, then that leads into all kinds of questions the students have. Well, how much rainfall do we get per year? Now we're looking at averages and statistics. How do we collect the water? So now we're looking at, well, maybe we can put rain barrels and collect the water off the roof. Great. How much square footage is on the roof? On an average rainfall, how much water are we going to collect? And do we have enough volume in the containers that we have to collect all the water? How much per plant does the water need? What's the most efficient way of using that water? If we bought it from the city, how much does that cost and why? These are questions the students are coming up with to solve a problem. And instead, we're using mathematics in the moment. So no kid is saying, well, why do I have to learn about averages? It's the opposite. They're like, we have to understand this data so we can solve our problem. And that makes so much more sense. Things in the community. Here we live in the city. And I know a lot of urban schools do studies about their areas. They learn about where they live and who the people are there. And so doing things like looking at the ratio of grocery stores per person or per area. And they talk about things called food deserts in the cities where people don't have access to fresh food. They only have access to maybe a convenience store, which has expensive, prepackaged, high sugar content food, not fresh food. So all of a sudden, then they're going out and they're collecting data. They're doing mapping. They're doing area and statistics to solve this. And then they look at they say, well, there's not a lot of grocery stores around, but there's a lot of liquor stores around. Let's go ahead and graph those now and see what the difference is and why. And what are the laws that are being made? And all of a sudden now it's a social justice issue for our students. And when there's issues of justice at this age and they see it and they want to get involved, they want to be armed with the tools to go ahead and make arguments, to make a change and to make a difference. Our adolescents are not passive people. They might seem like a stereotype is that they're lazy, that they don't want to do anything, that they're lethargic. But I believe, and I think most Montessorians believe, that when we see those kinds of behaviors, that's an adverse response to them not having a properly prepared environment. That's their reaction to not really having anything meaningful to do, and you get lazy. I remember when I worked in college. I worked for the city, and I cut grass. And we get out and we'd mow the lawn all day for the different parks, and it was hard work, but it was good. There were some days though that like I'd be sitting around with the boss, and the boss would be like, "Hey, let's just go over here." And we kind of didn't do anything for the day. And at the end of the day, I was exhausted. Or he'd say, "Get out. We have to go do one thing." And I'm like, "I don't want to do that because I've been sitting all day not doing anything." And all of a sudden, it was so lethargic. I felt more energy when I was working. And I think our adolescents are the same way. That when you do more work, you feel better and you get energized by that work. It's not the kind of work that weighs you down. And we see this all throughout Montessori, where work where work produces energy, not takes away energy, and you get more excited as you go along. And we've all had these experiences, even in my teaching. There are some things like right now I'm talking fast, and I apologize. I have to slow down. I start getting wound up, and I'm getting excited. So I've had a long day today, but I'm getting energy as I'm talking to all of you wonderful people. Like I'm excited about the topic, and I'm going to leave this talk in an hour, and I'm going to be wound up and wanting to do more work than I did an hour ago. We just feel that. But teaching, if I'm grading papers, oh my gosh, like or writing reports, like the hour couldn't go by fast enough. It's just like I'm so tired after that, and I can't get through it. But other things just bring life to you. And so for our adolescents, we need to create an environment that's life-giving, that's energy-giving. And it starts with work being at the center. And that's always key in a Montessori environment. Oftentimes, people will say, well, we want to do projects, but we don't know how to fit them in. We don't know how to get the students to work. And it should be the opposite way. It's like, no, how do you get the skills to fit in? Like it should all be around work. And then you have to look at your skill list and say, well, which skills am I getting through the project and which other things do I have to find new ways? Not like, well, here's our skills all day and when do we do the projects? So we need to rethink that environment. And if we do have an environment which is project-based, then it's always a question of how do I get the students more involved? How can I give them more independence? How could they have more freedom? How could it be more directed from the students and less directed from the adults? Now, that's not to say the adults don't have a key role, especially for the adolescents, because in the adolescent environment, adolescents are like social newborns. That's what Montessori calls them. And they're learning how to become adults. And part of that training on how to be adult is not just intellectual knowledge, but it's this social knowledge. And the adult that they see in their environment is usually their teacher. They spend probably more time with you in their waking hours than they do with their own parents, or at least the adults in the community. And so, those working side by side with adults, they're not just learning from you the content, but they're watching how you behave. And they're watching how you interact with other adults. And they're watching your love for the subject and what you get excited about. And they're really modeling a lot of that from the adult. So the adult is really, really key. And I talk about this as well, about the attitude of mathematics in an environment. And, before the beginning of the school year, we'd have a picnic where we'd meet the parents, we'd meet the students, kind of this nice social event to kind of, for the parents to meet the teachers and the students are there. And I would have parents who would come up to me and would say things like, oh, my daughter, she's not very good at math. She always struggles with math. She's not a good math student. And the mother or the father would say that with the daughter standing there. And I'm just like, you're like, why would you do that? Like, why do you say, and it's okay. The parent's like, well, that's okay because I'm not good at math either. I was never a math person and she inherited that from me. I'm like, really? Okay. So if I'm not a great reader, is it okay to say, well, my kid doesn't read? That's all right. I'm not a good reader and they don't read. Or, you know what? I'm not really good at hygiene. So my child has no hygiene. Like you don't accept those things from anything else. But for some reason, it's okay to not, it's okay to to not like math or not to be good at math and for that to be really acceptable. And I know that doesn't generally come from the math teachers, but it can come from other teachers in the environment, where they kind of, have some math and they go, oh, well, I don't know. That's numbers. I don't really do that. And what do the students see? They see this attitude from high functioning adults that they respect that are saying, well, I'm not a math person, so this isn't for me. Like, I can't say that about reading. I can't get a memo from my head of school and say, oh, well, I really don't want to read this paragraph. I'm not really into reading. Like, you just don't have that attitude with other things. And so um, the adults in the adolescent environment are just so critical to set that tone, to prepare the environment so that the students really become at the center. And that's really the art of Montessori work in general, is to prepare the environment to have so much control over the environment that nobody knows you did anything at all. I think that's actually a quote from Futurama. I don't know if anybody's ever seen that show, but I think it was Bender the robot, and he was out in. Sorry, I'm going off on a tangent here, but I really like this quote. He was off in space, and he had these little creatures living on him, and they thought that Bender was God, and he kept like messing everything up and destroying their lives. And then he met the real God, and um, you know, he said the trick to being God is to do just enough so nobody is sure if you did anything at all. Because if you do too much, then you're interfering. And if you don't do enough, then you're abandoning. And I think, I'm not trying to say teachers are God. Please don't misconstrue what I'm saying. I know this is recorded, but oh my gosh, please be gentle with what I'm saying. But I think teachers have a similar role in the fact that in a Montessori environment, if you've done your job, nobody's sure that you've actually done anything. Because people would walk into my environment and they can't find the teacher. They just see a bunch of kids doing stuff all day. I mean, this is on ideal days, okay? They just see the students working, and you've seen this, and you can't find the teacher in the classroom. They're just over with kids, and the other kids are working. They're doing things. Kids come in, they don't need the teacher to start the class. At the end of the time, the bell rings or whatever, and the kids aren't already packed up halfway out the door like it was when I was in high school, right? In high school, we'd be watching that clock. And if the class ends at the top of the hour at 3 minutes till, what do you see? You're rushing, you're putting things in your bag, you're getting ready to go. The best days was when I was teaching the math class, and I look up, and we did have periods where we did have the move for parts of the day. And I look up and I see about 4 kids standing at the door. I'm like, what are you guys doing here? They're like, oh, well, we have class now. And I'm like, oh my gosh, like nobody in the class has moved because everybody's like doing work. And so I ring the bell. And then I hear, oh, from the kids. And that's the greatest sound and the worst sound. It's the greatest sound because that means all the kids are engaged, right? They're doing their work. They're like, I didn't even know what the time was. I was in the mood. I want to keep working. And that's what also breaks my heart because it's like, why do they have to leave? Like if you're in the middle of doing something, like that's like a form of torture. Montessori said that the only form of torture that they would do to the monks was that they could never finish a task. That as soon as they are into something, they stop before you can complete it. And that's what she said about, having periods where you go from 1 hour to the next hour to the next hour, you can never finish. And, so we were always trying to find ways in different environments to break down those artificial barriers. Like, yes, you need classes. Yes, you need to move together. Yes, you need to have social organization is important. But how do you then balance that with the need for students to be in charge of their own learning, to do things in their own time? And so that's a struggle as a school to find ways to balance that those social needs of the individual and the social needs of the community. And it can be done. There's a lot of different models that do a really nice job of that. But I just want to say that that Montessori environment is just so beautiful for allowing that work to happen. And it doesn't happen in my environment every day, and it's not always perfect, but I'm always working towards that. You're working for that attitude, where it's their classroom. It's not my classroom. It's not even the math classroom. It's a place where students come to do their work, and they're not there to watch me do my work. They're not there to listen to a lecture from me. Um, when I need to give students a lesson, oftentimes, I say, hey, I need you for a lesson. They're like, well, we're busy. We're working. We don't have time for you. We're doing our math, and that's great. But most of the time, though, I try to structure things where students are asking me the questions. They're asking me for help. Like, I'm not going to them, but it's where, hey, you're working on something. They're like, I don't know how to do this. I have questions that are beyond me. I'm going to go to the teacher and ask. And so they'll come to me, we'll work on it. And then there's another group. Hey, Mike, I have a question on this. So as much as possible, I want them to ask the questions. And, the Montessori environment, it happens so naturally here. When I first started teaching, I had some book. I don't think I have it anymore, but it was like for new teachers and kind of like the first day of school. It was called something like that. And there was a statistic in there, I think, where it was something like teachers, the ratio of questions that the teacher asks compared to the questions the student asks is like 20-1 in an average classroom. In other words, the teacher is asking 20 questions for every one question the student asks. And if you think of a traditional classroom, the teacher saying, well, what's the answer here? And who did this? And what happened there? And the students rarely get to ask their own questions. In a Montessori environment, we want the students to be asking the questions. And if the students are asking the question, if it's coming from them, then it's really their work. When students do their work, they don't ever, I never want them to say, oh, I have that paper for you. I have that report for you. I have this work for you. They shouldn't be doing it for me. Like, they're doing it for them. And actually, I remember in my elementary training, Mrs. Grazzini would say, we'd do a lesson and we'd practice and we'd say, oh, can you move this square over here for me? And she'd ring a little bell and say, you don't ask the students to do it for you. You just ask them to do it because it has to be for themselves. And so as much as possible, that's what we want to do in our environments, is to create an environment of work, of real work, which again can be practical. It can be work in their community. It can be based on the student interest. I love doing work that's based in history. So doing things like, if they're learning about ancient civilizations, and you're learning about where they lived and you're learning about agriculture and all those kind of things you would learn in an ancient civilization. One of the most impressive things that ancient civilizations came up with is mathematics. It wasn't something separate from the evolution of history. It's part of history. Because if you have a civilization and you're settling down, you need to know when to plant the crops and when to harvest. And how do you determine that? Because you can't miss those days. You need to have a calendar. You need to watch the stars. You need to be able to count and account for the happenings in nature. You need to be able to follow patterns. You need to be able to distribute goods and products in a way that you can keep track of. Mathematics is a natural thing that comes out of living in a civilization and therefore allows civilization to happen. And so if you're studying ancient civilizations, the Mayans, they had base 20 and they had a 0. The Babylonians had cuneiform. They did it in base 60. And we look at the clay tablets that they would use, and they knew about the Pythagorean theorem, thousands of years before Pythagoras. I think thousands, probably way before Pythagoras. They knew about the Pythagorean theorem. There's story problems on these cuneiform tablets, and we'll do those with the students as part of learning who the Babylonians were, or learning who the Indians were, or learning who the Mayans or the Native Americans were. By learning about who they were as people, you have to look at all aspects of culture. And mathematics is a part of culture. Yes, it's for practical work as well, but what do human beings do if not work? That's part of our nature, is to work, is to build, is to create. And you can't do that without having an understanding of mathematics. And so tying it into things that students are studying and learning about anyway is really important as well. Okay. So I think that seeing mathematics as part of life and not something that's separate from it is really important for our adolescents. That it's just kind of what we do. It's who we are. It's in our nature. Both our minds work that way, our civilization revolves around that. And there is a time to learn about certain skills in math, but if it's connected to things students are already doing. So for example, when I was at the farm in California, at Grove, the students had chickens. They had a few chickens, and they wanted to have them be free range chickens because they thought that was more more good for the environment, more healthy. But there's regulations about how much square footage you have to have for each chicken. So they needed to redesign all of the chicken pens, and they wanted to do this on a budget. We had fencing that was already there, and so I said, well, okay, so we have all this fencing to make the perimeter. What size should we build the fences? How can we maximize the area that we have? And should we put it against the barn where we just use 3 sides? We did all these different configurations, and we made charts of the different sizes of the areas for a given perimeter. And when we graphed those, we ended up with a parabola. We had a quadratic equation. And now all of a sudden we're studying, we want to maximize this. So we have to find the peak. So given all these different perimeters, how can we find this? And all of a sudden then we're doing a study of quadratic functions. We're eventually leading to the quadratic formula and factoring and all those skills students will need. But now they're open to understanding that because we're talking about maximization. And then we say, well, what else could we maximize? They're like, hey, wait a minute. The kid said, well, what about our profits? We want to maximize our profits too. So then they started doing surveys from parents about, they said, well, if we charge for our eggs, if we charge like 10 cents for a dozen eggs, I'm making up some number here, like we could do that, and we'll sell a ton of eggs, but we're not going to make any money. But if we charge like $10 for a dozen eggs, we're going to make a lot of money, but we're not going to sell very many. So again, by doing the graph, by taking real data and doing surveys, they found what they figured should be the maximum profit. Where's that sweet spot where you're not selling too much, but you're not charging too much. And that comes out of the real need. And so then when we're studying about quadratics, and I give students the algebra tiles and the materials, and we're practicing factoring, they're not saying, well, when am I ever going to use this? They're actually asking, how can I solve this problem? Give me some skills so I can do this. And now all of a sudden we're really steeped in this work. And that's what's really great about the adolescent environment in particular. Overall, in mathematics, we use materials. And a lot of times people are hesitant to use materials with the adolescents because a lot of times the adolescents will reject those materials. They'll say, well, they look at the materials as being something they did when they were little kids. And if we use materials in the same way in the adolescent environment that we did in the elementary, students should reject them because they're not adolescents anymore. Just like if you did the lessons for elementary students the same way you did for primary students, with like no words, using your hands to feel the shapes, if you've ever seen a primary lesson, they're absolutely beautiful and they're great for a 5-year-old or a 4-year-old. But there's no way that same lesson should be taught to a 7 or 8-year-old in the same way. Likewise, we're not going to teach students in the adolescent the same way with materials as we would do in the elementary. But students will use materials if they're developmentally appropriate, if they have a context with them, and if students use them for understanding very complex ideas as well as beginning ideas. So let me just give you an example. There's a material it's a beautiful material. I brought mine here. This is the Binomial Cube. You probably have seen this before if you've gone into any elementary or primary environment. And what's great is this is a material that's actually used by primary children, ages 3 and 4. And they use it like a puzzle. So what they'll do is they'll take the shapes and they'll match the colors and the sizes. They'll take this apart and they'll put it back together. And it's the sensorial cube. They just use their senses of touch and of sight and color to disassemble and reassemble the cube. The same cube, the reason it's called the binomial cube, is that when students get to elementary, they're going to be multiplying, they're going to be squaring 2-digit numbers together with this and cubing 2-digit numbers by using the same material that is familiar to them because of what they've done in primary. So we're teaching them about this concept of binomials, but we're doing it sensorially and very indirectly for the very young child. But then for the elementary child, we're doing it numerically. And then we move to this cube, which is the same thing, and we do it algebraically. For the adolescent, I'm going to share a couple of pictures with you here for a moment. This is some work that took a screenshot of a film that one of my students made, where they're taking the same binomial cube that they did in elementary, but now they're using it to calculate the difference of cubes. So this is a cubed minus b cubed, and they rearranged it, did it as a volume, and did it abstractly. This work then is very high level work, and it's appropriate for, this is a high schooler that did this. So this was probably a 16-year-old young man who did this work here. Then what we can do with the adolescents, and I know this is done in elementary, but I love doing it with my adolescents, is taking the binomial cube, and instead of having something cubed, what would it look like to the 4th power or to the 5th power? And so I got this material, and it's when I had very few materials in my classroom, and these are 17-year-old students, and they're Montessori when they were children, and they saw the materials, and they were like, what do these do? And I said, well, I'm not ready to give you a lesson yet on these. They're like, well, can we at least open the box and see the materials? So they're doing a sensorial exploration of this, trying to figure out what this material does. And after a while, I finally did give them a lesson and show them how it worked. And then some of the students chose to work with the materials on their own after I gave the lesson. And so, you know, I just wanted to mention these. I took this picture. Notice the other kids in the background are not using the material. It didn't appeal to everyone, but for these two, it really did. And she was so excited to go ahead and label these. I don't know if you can tell the papers that she has there. Like, she was just tearing them. She didn't even get the scissors. She's like, well, I'm just going to make these and start labeling to figure out what this material does. And the young lady on the left, after she graduated from high school, she went to a very prestigious university here in the States, and I think is doing biomedical engineering, and she probably graduated by now. Into that material. So if you're saying, well, you know, oftentimes kids don't want to use the materials because I think they're for babies. But here we have, you know, probably my most advanced student in the school working with materials. That sends a message to the other students that, oh, working with materials is not just for remediation or for students who don't get math or who aren't good at math. It's can also be for very complex ideas. The young lady on the right, when she graduated from our high school, she did not go on to university. At least as far as I know, at least right away. She went around the country doing political protests and eventually opened her own art studio. Very different career paths once they left our school. But what's amazing is they are both working on this material together. Something spoke to both of these students. And if you can see the young lady on the right, she would always wear headphones in class because she said, oh, I just get distracted and the music helps me concentrate. But if you notice in the picture, where are those headphones? They're off her ears. Like, she really wanted to have, that's a sign of concentration. I don't want to listen to this music right now. I need to focus in on what's right in front of me. So I really love this photo because it really shows that students will use materials. And we have tons of materials, historical materials, materials that are new to Montessori, repurposing Montessori materials like you saw in the previous picture there, where we're doing them for higher purposes, as well as having students learn brand new concepts from a physical standpoint. This was some of her work that she was, their work that they were doing. They wanted to build the 6 powers material. They said, well, there's no 6 powers. Can we make that a project? So now all of a sudden she's like, okay, how do I design this? So this is her work right here that she was trying to figure out what would happen next. And even though she could do it algebraically, she wanted to understand the physicality of the material. And here she is. I think this is actually the next year trying to build and make that material. Just a really cool story, but it's what can happen when you have this type of environment and you have the materials in the environment. Montessori even says that in From Childhood to Adolescence, she says that Um, because of this vital importance of mathematics, the school must use special methods for teaching it and make clear and comprehensible its elements with the help of plenty of apparatus that demonstrate the materialized abstractions of mathematics. And so really she's talking about materialized abstractions. Abstraction, again, we talked about that in the beginning, is to draw these ideas out, okay? So in mathematics, there's concepts like balancing equations and ideas of an inverse and of negative numbers and things, like a negative, like that's a quality. You can't actually see a negative. That's an abstraction. We know what debt is. We know what things below sea level are. We understand that negatives have some meaning, but we can't see a negative. But yet we can make a material that makes that real, so we can hold it and understand it and manipulate it and work with it in a new way. And so, doing things like, for our very young students, learning about positive and negative numbers, there's a material that we use for that that's very, very successful, that really students get to see. They develop the laws and the rules for themselves. And that's so important in Montessori mathematics, that rules are a point of arrival, not of departure. We never start by giving the student the rule. We start by giving the student work. And through the work, they come up with the rule themselves. So the rule has meaning to them. And then if they ever forget the rule, they can just go back to the materials or use the materials mentally and understand what they've done. And so, but even more so with our adolescents, if we just give them the materials, the green and the gray counters, and have them do they can do all the work and come up with all the rules themselves. And it's beautiful and so much better than just memorizing we give them the rules, say, here's how you do it. Now practice it 1,000 times so you never forget. That's what, that's how I was taught it. Instead, students discover it themselves. However, what's more important is for adolescents they should be working with positive and negative numbers in some real way to connect it to the abstract work that they're doing. So, do they have a small business that they're running? Do they have debts? Do they have purchases? Do they have things where they're dealing with negative amounts and positive amounts? Where else are they seeing positive and negative numbers? Are they working with temperature? Are they working in a science class? Are they working with geography? Where can they see positive and negative numbers? Because we have to tie that into something real and concrete. So there's so much concreteness that happens. There's so much work of the hand that can happen. And so often, if you look back again to my notebooks when I was in high school, it's just all on paper. No pictures, no drawings, no context. Here's some rules, follow them, work through it. And some students can get by with that. And some students really like that, but it's a very small percentage. That's not mathematics for all. And it's definitely not developing the mathematical mind for all of our students. We can do so much better than that. And that's really why I appreciate so much a Montessori environment, because it allows, schools should be a place where students go with joy, to go to have fun and to create and to do their own work. I read a book. I can't remember the name of it now. Something about the adolescent. But yeah, that'll really help. So go ahead and look up that book. It's called Something About the Adolescent. I don't know. No, it was, but it was talking about that it can be talking about depression that sets in oftentimes for adolescents. And, it's very, if you tell a 12-year-old why they have to, you have to go to school so that you have to do well in your younger adolescence so you can get into a good high school. And why do you have to do well in high school? So that you can go to a good college, so that you can go to a good graduate school, so that you can get a job. How many years away is that? That's like 8, 10 years. And we're talking to 12-year-olds. So basically, if you're talking to a 12-year-old that they have to wait 10 years before they do anything meaningful, that's literally an entire lifetime for them. I mean, they're only probably conscious for 6 or 7 years. So for them to imagine something that's 7, 8, 10 years down the road before they get to actually contribute or do anything meaningful, you just give up. That's insurmountable. There's nothing there. And that causes a lot of difficulties for our adolescents. Instead, we can give them real work right now. Again, when I was at Grove, and I wasn't at the middle school, but I was at the high school for a while as well. It was called Grove because it was set in this beautiful grapefruit groves and orange groves, a very kind of agricultural area with a suburb around. And of course, the urbanness is encroaching in. So there was a lot more traffic, and we had a 2-way stop sign at the corner. But people wouldn't know it was 2 ways. They thought it was 4 ways, and people would start going through the light, and there was like accidents were increasing. And one of our students got in a serious accident at that intersection. And so the student said, well, we have to do something about this. And so they wanted to go to city council and advocate to the traffic commission to get a stop sign put in. So what did they do? They started doing surveys. They started saying, well, how can we tell if people are speeding? They didn't have a speed gun back then. So, okay, let's set up an experiment where we can tell how fast cars are going. Let's do the math behind that. Let's collect the data and let's present that to the city council. They're taking real action. They got that stop sign put in. They made a difference in their community right then and right now. And now they have meaning with things. And students do this all the time. They can hold forums. They can hold community gatherings to discuss issues. They can advocate for their schools. They can advocate for their communities. And there is real work for them to do right now. Whether it's in their classrooms, their school, their city, wherever. We need to get students engaged in that. Just for their sakes. And whenever we take social action, whenever we want to make changes, I guarantee there's some sort of mathematical aspect behind that. There's some data to collect. There's something to analyze. There's some arguments to be made that are logical that we have to put together. There is real work there for the students. And it's just really up to us to find it. And so, I love the Montessori environment so much because it allows, it encourages that and it allows for that and it embraces that. So often, we talk about student-centered learning, or we want the students to be engaged and all this. But what does it end up being? The teacher in front of the classroom directing things just kind of in a fun way. We have to reverse that model. And we have the tools to do it. We have materials from Montessori that she's developed from elementary, and we can adapt those. We have structures that allow students to be engaged. We have students who are well prepared because of what they've, when they come to adolescence, if they've had a good primary and elementary experience, the kids are longing for this. They want it. They are ready to take action. And it's just up to us to prepare that environment and prepare it so well that we can step back and nobody would even know we did anything. That's really the key. Where students come in, they're like, yeah, I guess there's a teacher here somewhere. I guess the teacher did something. I don't know. I'm just too busy doing my work. It's a lot of work to set up that classroom so the students can be fully engaged. They have the tools they need to be successful so that they're getting math lessons all the time without even knowing it. And it's the right lesson at the right time. So to me, that's what a little bit about what I think is the Montessori approach to math. I did want to leave a little time for questions and answers. I'm sorry if I talked really fast. I promised myself I was going to talk slow and to be clear, but I just can't do it. I'm sorry. I just get too excited and there's so much to say. So I hope that was okay for everyone. I know Erin's recording it, so you can watch it. You can watch it again. But I have about 10 minutes left. So if there are questions, Erin, are there questions in the chat? And if you want to direct them my way, or if you think of a question, you just want to, there's 67, oh my gosh, 84 people. Yeah. So you probably don't want to unmute yourself. I think that might be difficult. So throw a question in the chat. Erin can filter them to me, and then I'm happy to respond to anything that you might want to discuss.
Yeah, that would be great. Thank you. And I appreciate, we had discussed this beforehand, that this was going to be kind of the philosophical overview. So thank you very much. I appreciate hearing that kind of regrounds us, and then next week we were going to switch a little bit more practical to structure of a classroom is next week.
Yes. Yeah. I'll be talking more about so this is great. And hopefully people are saying that sounds wonderful, but how do I actually do it? What does the classroom look like? How do we make sure that we get the students what they need to graduate or to leave our school to be prepared for the next level, but yet still allow them to go their own way and be really independent and free? Those seem kind of contradictory, especially in a math classroom. So next week, I'll talk about a few ways that we can organize things to kind of be that invisible presence in the classroom for them. Some structural things that might be of value to some of you.
Yeah, so I mean, that's, and the questions, the question that has come in is from Kristen is, I really like the idea of the math teacher as a consultant on land-based projects, but yes, how do you make that work?
Yeah, I mean, I think, yeah, I mean, I guess there's how do you make it work with the project, then it's how do you make it work in the bigger structure of things, and I'll definitely talk about that in some more detail next week. So actually, I'm going to take a screenshot of that question and make sure that I address that exactly next time. So got that.
Yeah, and then
Yeah.
you know,
And I'm sorry not for answering it now, but I know it's such a big question that
yeah.
I just couldn't. That would be that'd be another hour. So
And then the other question that comes in, I know you know this well because of our good friends at Denver Junior Senior Montessori School, but how do you do this in an urban environment when you don't have the grove, the orange grove? You know, how do you do it in urban?
right. Well, and that's the thing is, I think some of the examples I gave were like that, like the urban planning, like, how do you design a city, right? How do you do surveys of your what are the needs of your community? That's basically what it comes down to. What are the needs of your community? And if you have a, now when I was at Grove on the farm, it was kind of an urban farm. I mean, it was a plot of land that was surrounded by, I mean, in the middle of the suburbs, so we could walk to, um, we were walking distance of Lowe's. When we needed things for our materials, we could walk up to Lowe's and do our shopping. Because the things start moving in. Here in the city, there's just tons of opportunities. So it's really looking in your environment and seeing what you have there. Every community has challenges. Every community has needs. And so when your students are invested not just in their classroom community, but in the wider community, then that's where the projects can come from. And they can be, if you're in a city, you have different opportunities. I mean, you can get on a bus and you can go down to the downtown area like easily and solve problems that are there, or discuss larger issues. Especially with there's lots of issues. Yeah, just a lot of issues that come up. So it doesn't have to be on a farm. Definitely not. We're lucky to have a small area of land to do those things with. But I mean, you can run a business anywhere. You can do anything. You can make kids can make and build and create and have a business. I think just having some sort of business wherever you are is a great way for students to get involved in the economic side of things, in outreach to the community, in creation, and tons of mathematics. And whatever business you have, you can be anywhere and have that business. So that's what I would really look for is economic opportunities and social opportunities in your community.
So the next couple questions that are coming in, I'm jotting them down. We also may have to kick them to next week, but these are really meaty questions that come in quite a bit. The idea of how do you balance the student-led math class with public school requirements, and further, how do you ensure that they're meeting the requirements for your local requirements. So I know that's a big one, but we get that.
I think that's next week. That's kind of in that curriculum design more a little bit.
Yeah.
I won't have all the answers because
question.
Again, I do I think I do like a 2 or 3 week workshop in the summer where it's like all the details of all those pieces. But I'm happy to, but next week I'll just give a basic overview of a couple of models of how things can work. Because it can happen. So just know that. And then say come back next week for more details. But no, that's what I'll talk about next week. I did see one over here that I think I can answer. The younger adolescent and the older students, the differences. I think that there are definite shifts. I think they're definitely third plane. I mean, they're all adolescents. But I think part of what happens is as the adolescents get older, so we're talking as they start to leave, they become 17, 18 years old, they're ready to go to that fourth plane. They start to take on that calmer characteristics of the fourth plane child. So if you know the chart with the triangles, the Montessori chart with the 4 planes of development, there's the 2 blue and the 2 red. They're leaving the red turmoil phase of adolescence, and you kind of see this more calmness when they get to that age, at the end. So sometimes, that takes a different quality in the classroom. The biggest thing that I see mathematically is the younger students need to know, when am I going to use this? And that's a question you have to answer. They don't care, but the older adolescent will ask, when is this being used? Why is this used? And there's a subtle difference between that. So if I say, if I tell a younger adolescent, well, this is used in physics because of this and this, they'll say, well, that's great, but I'm not a physicist, so it doesn't apply to me. The older adolescent is more curious about the adult world that they're just about to enter. So they can look at that and say, oh, I see how this adult would use this. I see why this career would be involved with this. They're a little bit more open to not having everything be immediately about them personally, but more how it's being used as they're going to enter that larger world. So it makes it a little bit easier in the math classroom, I think, to present more abstract concepts, because even if everything doesn't, you want to tie everything as much as possible to the student's personal life, but you can't do everything that way. So you have to find other ways to do that, whether it's through history or other things. I think the older adolescent is a little bit more willing to do learning because of learning's sake, again, kind of like they were in elementary. The younger adolescent struggles with that a little bit more, and that's why I think it's more important for the younger adolescent especially, that as much as possible, it's things that are related to their lives right then. You still want to do that as much as possible for the older adolescent, but I don't think it's quite as critical psychologically. And then there's a million other differences, but yeah, I mean, they're both fun in their own way. So.
All right. Well, we are at the top of the hour, so we will. We're keeping track of these questions. We will try to address them at the start of next week, or just as the week goes on. But Mike, thank you so much. I appreciate it. You'll get, anyone who is on this call or has registered will get this recording in an email sent to them tomorrow. And other than that, please have a great week and take care of yourselves. Thank you for all that you do for your students. Thank you.
Thanks so much, everyone. So great that you joined us this evening. Hope to see you next week and in the future. So have a good one, everyone. Thank you.